Ladies and gentlemen, today I'm going to talk about unleash the new DNBSEQ power, revolutionize the sequencing. And as you already know, MGI is celebrating the 10th anniversary of its innovation about DNBSEQ. This is the 10th year for DNBSEQ. If we all recall, MGI is only about 9 years old, but why we have a technology over 10 years. And this is because we acquired complete genomics that existed before MGI. So if we go back about 10 years, in the end of 2015, at that time, we just launched our sequencing technology. That time we call DNBSEQ 500. But internally, we have a lot of discussions on what would be the best to represent our technology. We have been used MGI-seq, or at some times we talk about CGI-seq. But in the end, three of us discussed in one of the December afternoon of 2015, why not we put DNB plus seq together? DNB stands for DNA nanobore sequencing. And John just joined us, Johan just joined us, and Roddy is our CSO, and I had meeting in the afternoon of complete genomics. And this is reset in our mind. We should use our technologies to drive and make the mark for our sequencing technology. This is how DNBSEQ come about it. So it's almost 10 years for these technologies. We have been going a long way. We create a lot of technology within this these technologies called DNBSEQ. And this is basically mainly focusing and use DNB nanobore to create sequencing libraries. When we use DNB nanobore to create sequencing libraries, inherently, we have three advantages. One is very high accuracy. Second is very low duplication rates. And third, it's very low index hopping. This is the signature for DNBSEQ. We combine this with pattern array and other sequencing optical detection methods. We create this powerful sequencing technology portfolios. For detection technology, we used 4-color sequencing, 2-color sequencing, and 1 color without illumination. And recently, we have a newer technology called cyclone-seq without using light. Also, we invent a couple of sequencing methodologies or chemistries. Sometimes we call cold hot MPS, cold MPS, or standard MPS. You will see a little bit in this presentation. So with all this sequencing technology we put together related to DNBSEQ, we create whole sequencing methodologies and sequencers. All the sequencing technology we will use DNA to extract it from human samples and create single-strand DNA, and then use the single-strand DNA combined with the rolling circle amplification, create a DNA nanobores. And we load DNA nanobores on a pattern array and then do sequencing with this methodology. We unlocked a range of applications from kilobytes to megabytes. And also we extended into long reads recently. With this technology, we had a lot of publications throughout this 9 or 10 years. You can see the publication increase. This year, we're expecting more than 3,000 publications. If you accumulate over the last 9 years, we have about 10,960 publications. This is another way to demonstrate the DNB sequencing technology actually works, not only works, and had huge impact in the scientific community. With also this technology, we combined and built whole sequencing platforms. And if you know MGI, actually MGI not just a sequencing company. We have 3 product portfolios. One is DNA sequencer related. We call all sequencing product portfolios. And another one we have based on our automation systems, create another product portfolio we call GLI, Genetic Lab Intelligence. This is a combine all of our automation instruments and some combination of integrated solutions into one product portfolio. Besides this, we have third pillars of our product portfolios. We call omics. This including DCSP. D stands for DNA omics, C stands for cellular omics, S stands for stereomics, and P stands for proteomics. And also combined with innovative applications and also with our new omics tools. We put all that together, become our omics product portfolios. Today, we only going to focusing on sequencing all product portfolios. And within that, today we only try to go through what is new in our sequencing and sequencing technologies, and we're going to launch new products into this family. This is our sequencing product portfolio. And that's it's from G99, G50, G400, and to T1. Today we're going to talk about more, and T7, T20 times 2. Also, we have a E25. That's a cell luminescence sequencing. What that means, we use chemiluminescence as a sequencing detection methods is different from all of other existing luminescence sequencing. Also, we have another detection methods with DNA nanoboards without needs for any luminescence. That's what we call non-luminescence sequencing technologies. So based on all of that, we create all the different sequencing platforms to address different needs. But if we go back to look at the past 9 years to 10 years, we develop all of our sequencing technologies. And this is our development roadmap. We constantly battle or discussion 4 aspects. One is read length. Second is read quality. Third is reads, or you can think about it as a throughput. Also, we have a read speeds, how fast we can do the sequencing runs. So from the sequencing length, we go from SC35 to SC600 today. And we often use P150, although in most applications, P150 is good enough, but we are striving to developing this technology can read longer and longer. Also, for sequencing quality, at the beginning, we see Q20. Today, we are seeing Q40 as a routine. In the future, we can see Q50 is coming as well. For read throughput, E25 have 25 million reads, and for T20, we're talking about 40 gigabyte reads. So for read speeds, at the beginning for BJ-SIG 500, we have roughly 5 days per run. But today, and we can do 1 day per run. Some of them, we can do even 1 shift for the shorter reads to address some specific applications. So let's see what's new to T7. Everybody know T7 is our key sequencer, very useful in the market. There's 3 new things we bring into this platform. We bring into O-link library preparation, and combined with our circularization kits, we can really do proteomics on this platform. We will also launch the new methylation sequencing kits. This is allow us to do methylation sequencing on this platform. Also, we keep upgrading and integrating spatial genomics applications into this platform. Looking into the multi-omics applications, we empowering the methylation applications. And with this sequencers, we are also empowering the stereomics applications. As you can see, we have one-step DNB making reagents and high throughput sequencing primer kits combined with MGI high throughput sequencing sets. We will put all three together now and improve better sequencing visualizations for serum-seq applications. And also for Olink Explorer HT for T7, it's reliably used in our customer hands. So we work with Olink to combine their technology with our technology, putting this into our sequencer. Now we actually can do this example. We actually can do 172 samples, and then as you all know, Olink can read about 5,400 proteins, and with this platform, we have 344 barcodes. When we combine all that, we actually can really drive multiplexing applications, and then using T7 combined with Olink library and preparation methods to exploring proteomics, high throughput proteomics. That will be very exciting applications in the coming years. And for our G400 platforms, we introduced a new sequencing reagents we call DNBSEQ MPS 2.0. This gives Q40 sequencing quality. This it's the most versatile sequencing platform you can nearly use for any applications on this platform. Now we improve the sequencing quality. And not only that, we are also adding a capability to G400. We convert G400 into a new application. We call it G400 IS Flow Expert. What this does is add new functions, which is adding immunoassays fluorescence detections capabilities. Multiplexing immunoassay fluorescence detections use the G400 as image reader. And then we combine our new flow cell with new kits, antibody kits, put all this together, enable a new applications. This application, it will be very useful for the digital pathologists. Now, we combine the sequencer with the digital pathology readers together. This, we can see, will be enable a new field, not only for sequencing, but also for proteomics, especially for the imaging analysis. We can easily, reliably digitize the protein information with the staining. So with G99, this is the fastest sequencer we have. We also add new things into this application, these sequencers. We add a new flow cell we call FCU. This new flow cell will come in pretty soon. This have a 160 million reads. Now we have a sequencer not only fast, but also have a larger and wider flow read length, and also reads per flow cell. This increased breadth of the applications of this sequencer. Within all this existing sequencer upgrades, we're also thinking more, what will be the next innovations on DNBSEQ sequencer? How can we unleash the power of DNBSEQ. We think about 8 things in innovation. One is speed. Second is workflow. Third is how easy to use. Fourth, it's convenience for the users. Of course, we would like to have a sequencer can do everything in one. Also, the CapEx need to be lower, and the reagent OpEx need to be lower, much more affordable, and generate high quality results. We put all that, we did a 3 years research. Finally, we put our dream into one sequencer, particularly for the innovations related to the workflow. And this gives you also really high speed. We want to have a sequencer runs really fast, 24 hours sequencing. And also with this sequencers, not only need to be running faster, but also need to be very convenient. So this sequencer also need to address need to be in a T-level address almost all 8 wishes in our innovation desires. We have to do a long reduce the sequencing turnaround times, and also simplify the workflow. You think about the turnaround time is not only about the sequencing, but also how you're going to load sequencers and how you're going to clean up the sequencer afterwards. And then basically it's all hands-on time. We need to reduce those hands-on times. And with really high accuracy, multiplexing and multiple applications and really high speed, all of these factors, if we put it into one sequencer, it's hard, but we got this done. So this is 3 key factors. We put 3 key benefits or 3 key features. We put it into T1+. We want the sequencer really rapid, within 24 hours for P150 and generate 1.2 terabyte data. Q40 and with 90% of the reads, and also need to be very simple. We integrated DNB make and load modules into a sequencer. If you recall, when you use DNBSEQ before, you have to generate DNBs and then pull them together and load into a sequencer. Now we put all that into sequencer, and we have to have one-stop operations and integrate sequencing and the cleaning. That means we can regenerate the sequencer faster. Also, we want the sequencer to be very flexible. These 3 things I want to get into a bit more detail. How we can make it rapid, how can we make it simple, how can we make it flexible. Let's talk a little about the rapid. For P150, we can do it in 1 day. For SE50, we do it within 1 shift. This is very important for some of infectious disease applications. We want to turn around the sequencing results extremely fast. And also, we want to regenerate sequencer and clean them, prepare them faster. So then we can turn around the sequencer within 24 hours. And this is to set up daily sequencing routines. It's very important for us to have this. If you compare with the other sequencers, the regeneration part sometimes taking longer. So then you cannot really run it many times. We can see T1+. You can run it 5 times per week and generate 2,600 samples per year. This gives you 10 flow cells per week and 5 runs per week. It's extremely fast in instruments, and this is relative to almost full of other platforms we have. So how we can achieve this? It's larger data output. We use 1/4 of the time. How we achieve this? We advance 3 technologies. One is we have really high efficiency fluidic systems. We moved microfluidic flows extremely fast, twice faster than before. We also applied new TDI scanning microscope and gives very low noise, high speed imaging. Also, we create ultra high density flow cell. The flow cell will be twice extensive than before. And that's give you the capability to use much smaller area can create much more reads. We make the sequencer much simpler. We integrated DNB made and load into a sequencer. Now this is not a sequencer anymore. It's also integrate robotics from both sides, left-hand side, right-hand side. They put a left-hand side module, right-hand side module separately, and they can make and load simultaneously. And why is this important? DNB made and load, it's integral part for DNBSEQ sequencing technology. Now we create 3 entry points. We can load 3 types of DNA sequencing libraries into a sequencer. If you recall our sequencing library preparation process, we have to extract DNA, fragmentate, repair ends, and the ligate. After that, we do PCR amplification. When we do PCR amplification, we generate a double-strand sequencing library. So we can load this sequencing library into sequencer, or we can create single-strand circularized DNA and we'll load this into sequencer. Or we finish the rolling circle amplification, create a DNB library to load into sequencer. We make it very flexible now. We can create a sequencing library and any way we want it and load in a sequencer compatible with existing thermal and also Illuminous library preparation and our own MGI library preparation. And then all those sequencing library can be loaded into T1 Plus now. So we also make it very simple is to use a dynamic island. What that means is for the sequencer front, we have 2 screens. One screen to shows the status and then gives the user instructions, and also we can customize that. When we do DNB make, and this status tells you what's going on with the sequencer. And also we can load sequencing reagents with this step, tells you you are instructed to load the sequencing reagent. And also when you load the flow cell, and this static bar allows you to know what's the sequencing sequencer status. And also after we load all that sequencing libraries within 24 hours, and they give you the sequencing results from the sequencing libraries to sequencing results. And also finally, we can have a very flexible systems. This systems allows you individually address different barcodes and the automated loading. Not only no barcode required if you load it individual lane with a different application, different samples, or you can load mix the samples into the same lane. With all these flexibilities, we also have a dual flow cell, dual configuration, customer primers, and multiple input types into the sequencer. We talk a little bit more about the different situations here, particularly for the dual configuration. And as you know, we have 2 different configurations. One we call RS, another we call ARS. When we with ARS, we integrate bioinformatics modules into the sequencer. And this condition, we have a higher memory, higher high drive capacities, and also we have integrate bioinformatics tools allow you to trade WGS, WES. In other words, we put our megaball into the sequencer. And the T1 Plus, it's a slightly bigger machine than G400. The length is about 1.15 meters. Depth it's 750 millimeters. Height it's 810 millimeters. Weight about 292 kilograms. So very flexible. In another way, we have multiple flow cell and read lengths to enable rapid and cost-effective sequencing applications. As you can see, we have FCL, FCM, FCS, 3 type of flow cells for 2 giga reads and 1 giga reads and 0.5 giga reads with 4 different type of read lengths, SE50, SE100, P150, and P300. And it allows you to work with all different kind of applications. If you look at these 3 type of flow cell and 4 different sequencing lengths and with different run times, most important, most interesting is we all use standard library preparation reagents 2.0 that gives Q440 in a very high percentage. 90% of the reads have a Q40, high quality sequencing. So in terms of applications, we like to have a very versatile sequencers. That's why we put this whole sequencing technology together. DCSP, that's it, mostly for the for scientific research, but also can be used for clinical research. For scientific research applications, WGS, WGBS, RNA-seq, single-cell spatial genomics, it's very popular. We have all the software and the capabilities to run on this sequencer. We also can run clinical WGS and the oncology panels. For different applications, we have different recommendations for data size. For WGS, 30x 100 gigabytes per sample, typically. WGBS, 30x 120 gigabytes per sample. RNA-seq, 6 gigabytes per sample, and single cell, you generally require 0.5 gigabytes reads per samples. For spatial genomics, per sample is 300 to 600 million reads per sample. And for clinical WGS, typically it's 40x, 135 gigabytes per sample. For oncology applications, 10 gigabytes per sample, depends on the panel size. And we apply for different reads. Length P150 can be used for most applications except spatial genomics. And for clinical application, mostly with P150. From the right-hand chart, you can read, and different flow cells can apply different number of samples. This gives you a really good flexibilities for many of applications. Okay, I will show off a few applications, and this one is just a simple WGS sequencing. Mainly, we want to check the reproducibility of the sequencer. 12 runs, 48 lanes. You can see the right-hand side, the reproducibilities, all above 500 million reads. Lanes standard deviation, it's a 1.1 to 5.1%. And run CVs within 2.2%, really high stabilities for this application. And also you can see the WGBS. Now, when you run WGBS on T1 Plus, you don't need to add balance library anymore. This is a standard sample. We run WGBS. You can see the reproducibility and the really high, 99% of CU conversion rate, really good performance with unbiased data, right? So also you can look this RNA-seq examples. really good correlations with the 3 runs, and we generate gene numbers 19,000 and transcript number larger than 30,000, and then very good correlations. And also we have these instruments run with frozen mice brain tissues, and this is one of our DNBSEQ C series single cell library preparation, and then you can see really high quality with high capturing rates of cells and genes. And the right hand side is really good performance for the cell cluster. And these applications can run on T1 plus. Also, we use this for mouse brain slice with the stereoseq omnia FLPE library preparation, PE 75 reads. So you can see this is very high total reads numbers and very good gene per bin with a 20, right? So 2 runs, very good reproducibility, and the rapid WGS. And we use this for rapid WGS applications. And this is my favorite application. It's very interesting for using these applications on T1. Basically, you can use 1 lane per sample for father, mother, newborns, fetus, or with 1 proband lane to indicate what is the disease you want to add it. What that means is a positive standards you load in 1 lane, right? So what you do is use D4 library preparation machines to prepare 4 samples, and then load the 4 samples into one of the flow cells on T1 plus. This within 24 hours, you can get a whole trail sequencing and with 1 positive controls and rapidly to diagnosis what's the potential problem. This is a clinical research, and the example we used for proband with the fetal edema and civic lymphatic sac tumors and the multiple deformities. So this we collect the DNA from amniotic fluid samples, and then using the ultrasonic graphic to identify there are potential disease with polycystic kidney disease, and we do a diagnosis with this, and then look at the father, mother, and the fetus, and also compare with proband samples to try to identify these mutations. That's very good clinical applications to use for this. Also for oncology, liquid biology applications, lung cancer standard ctDNAs, we basically use this to run 8 times to try to see the sensitivities. And this is really good results to look at the 0.2% frequencies with SNV detection, 100% detected, no false positivity in the wild type samples. We can use this for diagnosis, prognosis, disease monitoring, and personalized medicines like personalized treatments like CDX, and develop with these machines. Okay. So with all that, we addressed this new sequencer. It's really simple, really fast, really easy to use, very flexible. So we called it DNBSEQ T1 plus. What that means, plus is they produce more than 1 terabyte data per day. They are not just sequencer, they're more than a sequencer because we integrate the DNB made and load modules into the sequencer. And also we integrate the dynamic island or the monitoring part into it. This is a smart machine. And also there are more than one. They have more than 1 lane, more than 1 slice, more than 1 screen, and more configurations into sequencers. And we also want to have more with you and our customers, partners to build one-on-one collaborations. You can develop whatever applications you want to use on this machine, and they will help you to advance your research. With T1 Plus in our MGI sequencing product portfolio, and we have a full spectrum of sequencer. We cover from lower throughput to very high throughput. This T1 Plus still within the medium to high throughput region. And I hope this can advance your research and then advance your applications. We are looking forward to working with you to advance the sequencing technologies in your applications. From our innovation to your innovation, we're looking forward to talk to you more. Thank you so much.